So I'm Chuck Bear. I've worked on the Vertica project for a long time. Thanks for watching my talk, Powering the Core of the Analytic Universe. Before I get started, the standard disclaimer about our roadmap being forward-looking applies. And perhaps just as poor as my recollection of which features are in which years of releases is the history I'll present to explain what it means to be at the core of the analytics universe. Believe it or not, the claim that we power the core of the analytics universe was watered down a bit from the first title marketing wanted me to run with. But as we go through Vertica's flexibility, features, and future, you'll see that it has the power to bring in all your data and provide valuable insights. Let's start with our core unified analytics principles. Principle 1, structured data is the best data. Some may say, is there really any other kind? The plural of anecdote, after all, is not data. But another way we know that structured data is the most important is that the first humans ever bothered to write down. Clay tokens and tablets clearly show structured data, and seeing as there's only one record per clay tablet, it must be a row store, probably from a transaction processing activity like livestock trading. Yes, some may argue that earlier paintings were also a form of writing, but these sort of pictures are for storytelling. And we still do something similar in analytics today. Principle 2, the more data in one place, the better. Centralize your data so you can combine it from different sources and types. How do we know it's a good principle? National Cash Register, NCR, maybe you've heard of their Teradata product. They didn't leave all the data in the point of sale devices when it was collected, did they? Principle 3, performance matters. You need answers quickly. The data has to be fresh. How do we know that's a good principle? Take, for example, the 1880 census, which wasn't completed until 1888, barely before the 1890 census was to start. Clearly, they needed better tools, so they invented some. In case you were wondering, the 1890 census was done in only 6 years. And they also learned something about the importance of backups and disaster recovery in 1921 when a quarter of the data was destroyed in a fire. Principle 4, you can't have too many algorithms and analysis options. How do we know this? Well, for example, there's this hot new field called machine learning. You can go to their 39th annual conference and learn all about the new algorithms developed in this discipline. Principle number 5, data management, catalog, security, access, controls, and governance matter. How do we know? Oh, never mind, that's super boring stuff. We have some concerns about this idea of sucking all the data into one central place, don't we? Isn't that going to be complicated, both technically and organizationally? Will it be hard to get data in if we have to curate it so carefully? Aren't we putting a lot of trust in a core vendor who might charge us a lot of money? What if the product is a bottleneck, or if they don't add all the features we want? So another approach was developed, Hadoop, which has gradually evolved into the data lake. Since it stores any file, it's super easy to get data in. The storage and software are cheap and may be free, respectively. The architecture is open to any data format, any tool, and you can use the local processor on the storage node to do some processing jobs. To some, Mike Stonebreaker and also David DeWitt, whom my daughter didn't sketch yet, this design represented a major step backwards, as it didn't follow several of the core principles of analytics at the core, in terms of data curation, query simplicity, performance, and so on. The community quickly realized that query tools were going to be necessary. Enter Hive. Now we had a somewhat primitive data language and catalog, but the data formats, while various, were not remotely competitive with the state of the art in terms of performance. We needed an open format for structured analytics. So of course, we got one. Well, we got 2 of them. These formats were also accompanied by more tools, like Impala and Drill. These data query systems had some of the elements needed for analyzing data with reasonable performance. But one thing open formats lack by themselves is a way to handle data in motion, to keep track of what data is current as it changes, undergoes compaction, etc. Options like Hive transactions and Kudu were developed to handle data in motion. But in the process, these locked out other tools from a coherent view of the current data. To solve that problem, we got a few more query engines to choose from. Actually, none of these by themselves solve that problem or make any headway on our other core analytics principles. They just fragmented the market. It became clear along the way that despite the open nature of the data lake ecosystem, projects were highly dependent on their corporate backers. Finally, in the last year or two, we are seeing a technology that solves the live data problem, allows query tools to see a snapshot of current data as it changes. This is Apache Iceberg. Oh wait, apparently there isn't only one. You did want 3 vendors' solutions competing to solve the problem, right? Anyway, there has been a remarkable evolution in data lakes in the last 10 years. Iceberg's a big step forward. Are all the gaps to modern data management now closed? Here are a few I think they've yet to tackle. The optimistic concurrency, wherein operations are repeated until they succeed, is primitive. The catalog can tell you which files are current, but which are no longer in use by clients and can be deleted. Without any notifications, caches become stale, and inquiries to the remote catalog must be made for the freshest data, which greatly slows down sub-second interactive queries. Physical schema design, governance, workload management, all well behind competitors in the established structured data management market. So now we've come around to the definition of the Unified Analytics Platform. It's a bit of everything. You can do what SQL data warehouses did at a much greater scale and with broad deployment flexibility. It does what data lakes will do when they grow up, and you can use it alongside your data lake. It's got a broad array of analytics features, data pipeline interfaces, and allows access by visualization, reporting, and external data processing tools. Sure, there's still some reliance on a core vendor, though one might argue this is true of all other technologies as well. With all the interfaces we have, we've minimized this as much as we can, and we're also unmatched on performance and deployment flexibility. So as we go through these areas in detail in the rest of the presentation, you'll see that the Vertica Unified Analytics is the solid choice. It isn't just talk. People are doing it today. It's great to see those customers we consider to be our data disruptors. If you want to see more about them, it's on our website. But there are companies like EOI Tech that really make good use of how all the pieces fit together. They get performance benefits from our efficient SQL implementation, use hybrid deployments, archive old data off to Hadoop for cheap storage, and get mileage out of our advanced analytics. Perhaps my favorite part of EOI Tech is how they use in-database machine learning. Running in database cuts down on the number of moving parts. It's a lot simpler, but it's also more efficient when moving data to Spark. It takes a few times longer than analyzing it. With that said, let's take a look at some of the Vertica Unified Analytic Platform features. SQL. Data analysis in Vertica starts with SQL and its associated ecosystem. SQL, the structured query language, is over 35 years old, with precursors going back farther. The best thing about it is that nobody's come up with anything better for selection, filtering, joining, calculating, sorting, grouping, etc. It's a price to play in analytics. Millions of people know it, and there's decades of academic research and industrial experience behind good implementations. We do SQL as well as anyone else does it. The biggest data sets, the fastest performance across industries and verticals. We're integrated into the data pipeline, integrated into the clients, the reporting and visualization tools. And I'm always happy to hear when someone manages to migrate to our database with minimal pain. It was great to hear Elisa's presentation at Unify last year about how they migrated from the Netezza to Vertica in record time. Taking out those old databases is still big business for us, and we're good at it. If you're attending the Unify conference and want to hear more about how a customer uses Vertica for a core data store and SQL queries, then starts using it to serve analytic queries against their data lake, and eventually branches out into machine learning, you should catch MassMutual's talk later today. Time series, an event series. It often surprises me that so many SQL-based structured analytics projects lack built-in time series analysis features. Time series, sequences of events, are very common. It's hard to think of data sets that don't have a time dimension, and understanding it is key to getting causal insights. You need to take data from irregular intervals and space it evenly using interpolation to join sequences of events that don't happen at precisely the same time, or to break one sequence into subsequences of related events, to count occurrences of temporal patterns in data. It fascinates me that there's such a thing as a time series database in the market. Some are general purpose and some domain specific. Their storage organizations sometimes make similar optimizations to ours, but they generally don't handle SQL tool integration well, wish they did joins better, wish their file access method was compatible with cloud storage, etc. You don't need to get a special time series database, just get an analytics platform with time series analytics features. Not all databases have it. We kicked a cheap, popular hosted database out of a home automation company because we process event series. Pretty obvious that an analysis of what goes on in home automation will need to examine events in sequence. Another customer does Internet of Things, in this case, high performance buildings, smart HVAC systems, which improve energy efficiency and reliability. Temporal patterns are key here. And some cases are less expected, such as Nostradata's use of event series in analyzing pharmacy data. But when you think about it, looking at whether customers comply with their prescription is a good use of conditional event and windowing functions. Didn't hurt that our performance clobbered the on-premise database they tried. They didn't want an appliance due to scalability and cost concerns, and the popular pay-as-you-go cloud database they considered didn't have event processing or time series. We have other data analytics up our sleeves. We have a supported package for geospatial indexes. We have network address functions, and customers who implement a bit of iterative processing find they can do graph analysis faster in Vertica than in dedicated graph processing tools. We have indexing for log text and semi-structured data, encryption and security. You can get a few more functions from the community GitHub or write your own. One of the most inspiring customer stories for Vertica comes from the Climate Corporation. They're literally helping to feed the world. Getting a few percentage points of productivity out of the cropland may not seem like much, but it's keeping people from starving. They do it by analyzing lots of soil data. The national and worldwide soil surveys they index cover much of the globe, and they match it to their own data. It's more likely than not that any parcel of the world's cropland is in their data set. We're happy that we put the engineering effort to help them work on this challenging project, which pushes the boundaries of what our geospatial package can handle. In the end, though, if it can handle all the world's farm fields and the path of tractors as they meander through, it can probably handle your data set. And climate is also another great example of how Vertica works in conjunction with other technologies. Looker is data visualization solution, Python and Jupyter notebooks, Apache Spark to pre-process data, Pentaho for ETL in the Amazon cloud environment. Machine learning. Putting machine learning in the database can be a hard sell for a lot of data scientists. They like the tools they like. They're used to getting a data set, loading it into their favorite tool set, TensorFlow, Python, Jupyter, etc., playing with it. Maybe only a sample if the data set's large, but a lot of ML data sets are not large. We had a customer looking at machine learning on ambulance rides. Even if that data covers the whole country, it's probably an in-memory data set these days. We can run a lot of ML algorithms in the database, the training or the predicting. But why would you want to? It comes down to operationalizing machine learning, using it in production to stay fresh. Bolting an ML system onto the side of your core data platform adds complexity. One more thing to know about and to manage. Data transfer between systems can be a bottleneck. Put it in the database. We can retrain the model on a much bigger data set much more quickly. We can manage the models for you. Once you're done exploring, put it in production right in the database. With Vertica, you get simplified machine learning at scale. Use the infrastructure and data pipeline you already have. Leverage model management and PMML. Enjoy better decision-making at lower cost. Customers like Pavas Retail have done it, greatly streamlined their model generation for pricing. Once you look, you'll probably find a use for machine learning too. To learn more about Vertica's in-database machine learning, consider attending our talk on in-database machine learning with Vertica Pi and tips and tricks for running machine learning at scale with Vertica later today. Complex types. In order to be considered for use at the core, to store all the structured data and interoperate with other technologies and lakes, a data management technology has to handle and optimize complex data types and schema per row, self-structured data like JSON. Handling complex data types isn't just for the purpose of logically organizing data like addresses, locations, or other structures. Arrays, sets, and maps allow data to be physically organized together for efficient retrieval, as opposed to normalized tables, which require joins to link, or deemed normalized flattened tables, which introduce unnecessary data latency. Vertica makes it easy to work with several common formats and can process them in rigid schema with complex types or in a more flexible fashion with flex tables. We have features for exploring self-structured data, detecting and inferring the data schema, and converting it to the more rigid columnar structures, which are more susceptible to compression and predicate optimizations. We do this at scale for companies like Adform. You can read more about it on our website, how they need real-time query against data that varies. And more information about our recent features, performance results, and a roadmap for complex types, check out Ryan's talk later today entitled Integrating with Complex Messages and Data Lake Archives. Deployment flexibility. If you trust any project, product, or vendor with a role at the core of your data management architecture, you're making a big investment. You want something flexible, something that will grow with you if your needs change. That's why we're proud of our unrivaled deployment flexibility and our recent Mutable Award 2022 from Bloor. We've always run on-premise on local disk. If you have relatively fixed needs and run your own servers, this is still the simplest, cheapest option. If you add object storage, you can pick up a few of the features associated with Eon, ability to add and remove compute subclusters on the fly. You can run in several public clouds on the object stores found there. You can embed Vertica in a product or its solution. And here, by embed, I mean take over the provisioning and management of Vertica clusters, maybe with containers or just using your own automation scripts. Or we can run your cloud deployment for you in Vertica Accelerator. You don't have to choose just one, of course. We give you the tools you need for hybrid deployments. Use cloud resources for extra demand, or use multiple clouds due to rules about geographic location of data. Giving you the option of the cloud you want, the storage you want, this is important to us. We're continuing to expand the officially tested and supported options, but others likely work if they're compatible, stable, and offer reasonable performance characteristics. Customers, Vertica, for example, but across many other industries, seem to love having these options. It's great to hear how they're not constrained by underlying infrastructure and that they've integrated with Hadoop, Data Lake, and Apache Spark. There are a lot of other products out there that aren't flexible like this. Maybe they're only hosted in one cloud. There's still some appliance offerings that will never run in the cloud at all because of the storage models used. Very few of the large-scale analytics products out there are suitable for embedding in the deployments you provide to your customers. If you want to embed Vertica in an end-user product, like another of our awarded data disruptors, Cisco, does with secure network analytics, we can help you. After all, what if your database is going to be run in a telco central office? Not just one windowless brick building, but one analytics deployment for each network in each city worldwide, thousands, all without database administrators available. You need something suitable for embedding. We're here to help with that. We have a range of options for you. We can give you all the commands you need to provision, start, and manage and monitor Vertica clusters. Or we offer recipes for container images, and our Kubernetes operator has gotten pretty good with auto scaling and online upgrade features. You can use it for provisioning in embedded scenarios, but you could also use it in your public or private cloud if it's based on Kubernetes. We've come a long way with containers in the last year. We did this by working closely with select customers. Yes, one of them was a key supplier of analytics products in the telecommunications space, one who has rack space and hardware in many cities globally. But we also see Vertica embedded in IT network monitoring products for data centers, storage monitoring, and security appliances. If you love containers, you're curious to know more, want to know how it works, I recommend Ryan and Matt's talk later today, Operationalizing Vertica with Kubernetes and Containers. In another aspect of flexibility for embedded use cases, Vertica is able to provide a solution for ARM CPUs. The core of Vertica scales up, but it can also be scaled down reasonably far, all the way down to a Raspberry Pi 4. But let's pivot back to cloud deployments and another way we can help you. If you want to run Vertica in your own Amazon Web Services account, we can help you manage it via our Vertica Accelerator offering. Our site reliability engineers, SREs for short, are available to help you with database administration, upgrades, provisioning, and other tasks. While we aren't able to reference them yet, we do have successful customers in gaming, pharma, and telecom. The one use case we can reference, however, is our own. We've recently become painfully aware of why so many companies would rather not run their own data centers. You see, they've been doing some work on our building to make it more suitable for lab space, a different kind of tenant. Not only are we not able to renew the lease at the end of the year, but they've been doing work on the ventilation system, and that construction has introduced a few leaks in the roof right above our 10th floor data center. So while we have a few servers we have to keep and move to a different data center, we've migrated our QA test data, the GRASP database we keep on our customer deployments, to the cloud, an accelerator, of course. If you'd like to learn more about what's happening here, consider attending Ro's talk later, The Future of Vertica in the Clouds. Integration and developer experience. If you're going to trust the technology for the core of your analytics deployment, you want, need, and deserve a degree of openness. Open to integration on the data pipeline side, query and reporting side, feature side, and platform and management aspect under it all. We have a lot of these integrations pre-built and pre-tested for you, and we're building more. We also have APIs in these areas and have ongoing efforts to improve the developer experience. On the data pipeline and query tool integration fronts, we're working on the SQL ecosystem in a few ways. First, we're shrinking the gap to Postgres compatibility. This makes it easier for people who've outgrown Postgres to migrate, but also makes it easier to work with tools that already support Postgres. Our Node.js driver is in the works. We're working on improved data integration with ML projects, particularly Spark, and updating the versions that are supported. We've completed projects on partition pruning for external tables, or improving support for Airflow, and adding support for Iceberg. Finally, lots of our customers, particularly embedded, have a lot of little files generated that they need to collect for load. We're working on having Vertica accept these directly over an HTTPS connection. It all leads to an architecture where you can move data faster. If you have shared storage in between, moving data faster in parallel has always been efficient, fault-tolerant, and relatively simple. But while a stopover in shared storage is good for logistics, making sure all the data arrives once and only once without complex coordination protocols, it does rob a bit of performance and requires an additional storage component. As we improve Vertica's session handling, extending session information to multiple nodes or the whole subcluster, we enable cases where data moves quickly in parallel without additional storage. The same improvements will also help with tools that load or extract data over lots of parallel ODBC or JDBC connections. They won't individually tie up cluster-wide resources as data trickles in over a serial connection. On the node and cluster management side, we're looking at HTTPS as an additional protocol for monitoring and managing the Vertica process. This enables integration with tools that are good at making standard web requests, but aren't as simple to use if database drivers are required to issue SQL commands. We're also adding what we currently refer to as a node agent. It's optional, but it's an open source helper that sits on the node and controls the Vertica process. It can be used to bootstrap databases, start the database, upgrade the Vertica binary, and do it all without the passwordless SSH employed by admin tools today. We have other ideas for use of HTTPS. If you also transfer native Vertica data over HTTPS, it becomes a handy building block for backup restore or to synchronize tables across clusters through one or more firewalls, enabling data sharing in truly hybrid deployments across infrastructural and organizational boundaries. If you put all the pieces together, you can see a cohesive developer experience strategy for all developers. Developers who use Vertica, developers who automate system administration, developers who automate the data pipeline, and developers who wish to embed Vertica in products for third parties. Now, some of you in the audience don't want any of the fancy features and are content with your on-premise traditional database deployment and don't foresee expanding or changing it. You just want to know that we've been doing something for you, what we've done for the core engine. And if you are using the advanced features and flexible deployments, you still want to know that we're improving the core engine. Our strategy and roadmap here remains steady. Some of our architectural changes are multi-year journeys, like convergence, which brings cloud simplicity on-premise and on-premise efficiency to the cloud. We're reworking the query optimizer and executor through incremental projects toward a long-term redesign. And we continue to work on low-level tactics, tuning, memory management, et cetera, that lead to higher throughput on shorter queries. For our optimizer, we've done a lot in the past year. We've used temp relations to support multi-part plans better and to do recursive with in an iterative fashion. Through the course of this year, not only are we continuing on our work with temp relations, but we've improved the cost model to get better query plans. This is all on the way to our optimizer redesign. We have professors and engineers hard at work to use the best research and some of our practical experience to develop an optimizer with dynamic execution order and to optimize through complex type operations like explode and implode. I've talked in previous years about our 5th generation executor and how it's a plan to optimize around temp relations for multi-part plans, client result sets, internal statements, and large merge operations. We've been working on our fundamentals, our sorting, our grouping. Our sorting and grouping are quite fast. We're still on the path to integrate them into our core operations. I mentioned in previous years our work on a task queue, something that is a blend of threads and tasks so that you get better system resource usage, so that short queries spin up quicker, so that Vertica controls the scheduling and prioritization, so the jobs that you want to have run first. We're finally seeing results from this. If you compare the result of a query in isolation to one that gets behind a slow background job, it might be very bad. If we put these in separate queues, it gets better. If we apply prioritization, it's better still. And in the lab, we're seeing that we can beat the original scheduling in isolation by making the scheduler faster and more efficient. I've mentioned that we're working toward a better buffer pool with a unified view of our memory management across everything, across our catalog, running queries, cache data that's been decompressed, and not using any of the C++ heaps or other things that are invisible. Over the last release, we've made great strides. You can now see visibility into queries in aggregate, as well as the global functions. And the little pink slice of pie that is the system allocator, or the purple slice, or you don't know what it is shrunk down to hardly any significance. We're also continuing our work on networking. Last year, we introduced a transfer service, which reduced use of spread and is cloud-friendly, competitive with on-premise. This enables some of our new features for convergence, a Vertica file service for file transfer, or moving EE5 temp relations from node to node. We've also reduced probe traffic, which has made our networking more efficient. This also has produced results in terms of reduced time to execute copy table, add column, and drop column commands across large clusters in the cloud. And it's a big step toward our convergence. Convergence, of course, is where you get all features in all deployments. The only difference in an enterprise without shared storage deployment and an Eon mode with shared storage deployment should be where the master copy is stored. In enterprise, we have to make sure that the local disks always contain a redundant copy of the data, highly available, where in Eon mode with the shared storage, the master copy can be entrusted to an S3-like storage. We've made great progress on this in the last year. In 2021, we had just gotten rid of the WAS. We had identical storage. We had network infrastructure for convergence, and we'd redesigned storage locations. Now we're sending ROS files over the transfer service. We can do remote file access. We have converged recovery, which brings clusters up faster. And we have resharding for databases that's done cold. Ongoing, we're working on multiple storage locations, multiple shared storage locations, subclusters in converged mode, and resharding your data hot while the database is live, one table at a time. We've also been working on stored procedures for people who need those in the core. Our version of stored procedures, of course, is for use cases suitable for analytics, automating data management, multi-step ETL or ELT processes, refreshing tables, managing partitions based on age. We also have analytics algorithms that are best encapsulated as a procedure, multi-step queries and reports, iterative algorithms like PageRank and nearest neighbors, graph algorithms like transitive closure. Housekeeping tasks, also something you can automate with stored procedures. Run scrutinize so that you don't have to manually run it to collect diagnostics. Collect system usage reports and user activity reports. Take a backup snapshot, or otherwise sequence administrative tasks. We've evolved our stored procedures a lot in the last few releases. Of course, it was new in 11. We've gradually added support for how you manage the procedures, what kinds of data type they take, how they handle recursion and input-output arguments, and we'll soon be able to schedule execution of tasks on a calendar or apply them as triggers. With all those features, you might want someone who's here to help. We try to keep things simple for you, but data processing has a lot of moving parts and will always be a bit complex. Vertica isn't just a product that you download and work through alone. We're here to help. There are multiple options for getting help depending on what you need. If you're doing it yourself, try the on-demand training at Vertica Academy, our videos, the documentation, and the forums. But we have solutions architects to help you get going pre-sales, support staff to help with simple incidents, and paid professional services for longer engagements. There are a number of presentations on operating and tuning Vertica already out there, and there will be 2 more later today. Johnny's talk, Best Practices for Optimizing Vertica Performance, and Sruthi and Chris will cover Beyond Bare Metal, Vertica Deployment Best Practices. Also, our developers love to hear from you. Feel free to engage us at lunch or the reception. Remember, if you don't want to deploy and manage your Vertica database yourself, would like to have your database hosted and managed, consider Vertica Accelerator. We have a variety of consumption models and various levels of service. This concludes our tour of Vertica and how it powers the core of the analytics universe for so many of our customers. Vertica's combination of a full analytic feature set, proper data management capabilities, high performance, deployment flexibility, integration with traditional SQL and data lake ecosystems, and commercial support make us unique in this cluttered industry. Thank you.